So I'll move back a little bit. So thank you very much for having me as one of your keynote speakers. Congratulations again. And I want to thank personally Grace Angel for contacting me and keeping up with my really busy schedule. So it was a really nice pleasure being informed about all these projects. Nonetheless, it's not only me presenting this, but it's also my collaborators who are part of this great project. This is the Protect Streams for Seas, really a Black international project. So part of what we've been doing, that's what I'm going to present. And it's going to introduce the nature-based solutions for the sustainable management of ecosystems. So based on what has already been presented, this is a more holistic approach ecologically and from a macro scale on how those agricultural lands can be actually protected so we can also be protected by the pollution. So here we are right now, Singapore. That's where the conference is taking place, just to get an idea of where Greece is. So we are a little bit quite far from where you are right now. So it's almost night here. At the introduction, you have been informed about the UNESCO Chair Connect, where I'm the director of the ecotourism sector. So as you can see here, this is a part of the team of international researchers that are taking place, and it's doing with a lot of conservation. So I'm informed, so I'm very well into the conservation, biodiversity, and of course we have here ecotourism of the riparian and deltaic ecosystems. So we're dealing a lot with water and how we can actually keep that clean. Also from the Mediterranean experts on climate change and environmental change, I'm really happy to be part of this great meeting that it took place prior COVID. So all scientists gathered to Venice in order to put the next call for the 2030 for trying to keep our climate sustainable and all our ecosystems as related to the potential changes that they're introduced by climate change. Of course, I'm also part of the International Council of World Tourism. I'm really happy to interact with that. And it's also a great key that I use in order to inform people on how to sustain our ecosystems. This is reaching people globally, like this international conference. So it's very important for me to be part of this action, as well as the part of the Inter-Balkan Women Cooperation Society, which is the society that is trying to incorporate peace at the Balkan area here in the EU. This is, you can see from the picture, we were trying to educate the youth from at least 10 countries at the Balkan area, how to proper transplant, what biodiversity is, and all this good information that it shouldn't stay only among us, the scientists, but it should reach the youngest audience, that is our children. So I'm also part of the board of directors for the Global Climate Smart Agriculture Youth Networking. I'm mentioning these because they're dealing with the production. These are part of my interaction here. As you can see here, at that area, I was trying to teach the audience, inform them about how to enhance proper transplanting while also saving the water, which is very important nowadays, how to save water, while also, you know, try to increase the production for our ecosystems. So this is a great effort. So now let's get back to our topic here. And I'm going to start for this collaborative effort. It's a project that has been taking place at the Black Sea area. As an overview, I will start a little bit introducing nature-based solutions and how this is incorporated with the agricultural areas. What are the objectives, the study areas, what has actually been studied, because this is the closing of the project, so there's some quite fair amount that we're still working on that, the research outcomes, of course, and the outreach efforts that we've done, because I do believe that outreach efforts are very important, including the publications that come up from the different projects. So, and all this for aiming for clean waters through the sustainable management for the Black Sea region. Let's not keep it to the Black Sea region, but also all kinds of regions worldwide, because water is very important, and that directly relates with the agricultural lands and production. So going back to my experience many, many years ago, if you Google to the Wikipedia trying to figure out about nature-based solutions, most likely you will come up with this site. As you can see here, they are introducing Bear Creek. I was fortunate enough to be part of this effort as part of the students of the Iowa State University at the US. We were doing many years ago. They were introducing those nature-based solutions. As most of you might know, Iowa is one of the greatest agricultural lands worldwide. A lot of corn, a lot of soybean, but the projects were running for the university. They were doing an outstanding work, introducing nature-based solutions many years ago. Right now, we're starting introducing those here in Europe. It's been the last 5 years that the European Union started introducing those projects. So getting a little bit acquainted what is going on, this is exactly the problem with the dead zone of the Gulf of Mexico. So what they were trying to do, Iowa is somewhere out here. I don't know if you can see my cursor, but you can see all that networking of rivers going through those agricultural areas, and everything is poured down to the Gulf of Mexico. So with this, we can see a little bit further the Mississippi River, where we have the sediments laying down at that area, and have the Gulf of Mexico right there. And with the color right here, we can see where the sediments are the most in that part of the Gulf of Mexico. This is where we have most of the rivers landing into the water, into the sea, the Gulf of Mexico, and that's where we have the dead zone. And this is, of course, you know, for the increased fertilization, that everything is poured down to the Gulf of Mexico, creating low oxygen levels. So it's characterized as the dead zone over here because many fish are dying there. So the dead zone of the Gulf of Mexico. So that's what they've been trying to do at Iowa State University. They were trying to introducing at the agricultural lands bufferings. I do believe that nature-based solutions is very important. You've been all informing us about production of microbial and all these kinds of interactions with the soils, with the production and things like that. What they're trying to create right here is a buffering zone where it's going to keep all the potential chemicals not reaching the water into the river. So you can see here from the photos, is the diagram and what has been actually been done at that area. Pretty amazing, a lot of work, a lot of research, many students. So this is a photo to get the idea of what is going on before and after, only 5 years after the establishment of this buffering. And right now, if you go and see and you have all those pictures, you can see what is going on with nature-based solutions, and pretty much is working with and embracing nature. And this is the final outcome. You can remember the photo that I showed you before, what it would look like, and now. And it's not only the looks of the area, it's also the benefits we can get from that area. And as you can see here, it's sustaining, increasing the productivity, the production, mitigating the climate change effects, the temperature, everything right there is different. The erosion, the pollution of those waters, it definitely increases the biodiversity, not just by the plants, but also the fauna that has been introduced at that area. Increasing the income. Yeah, of course, we have too many. We have trees over there to harvest. We can get wood, we can get fruits, we can get the prey game from that area. And in addition to that, it's also increasing the value of the land, the money that its owner is going to get from those areas right there. So with this in our mind, we were trying to introduce the same thing, trying to study how nature-based solutions can benefit the area of the Black Sea. So we're trying to stop the non-point source pollutants and the litter reaching from the streams and the rivers to the Black Sea. It's a cost-effective way to maintain a clean Black Sea that will actually benefit the entire region, not just the area right there, just based on the nature-based solutions introduced at that site, mitigating the pollutants and, of course, the climate change impacts of that area. So as you can see here, Black Sea is a closed sea. Gulf Mexico is fairly closed but open at the same time. But Black Sea, Mediterranean Sea, they are both of them closed. So they're more prone to pollutants and not changing that back once it happens. So as you can see here, we have 5 partners. So this is 5 different countries. We have the Baltata River in Moldova, the Suri Lake in Romania, the Agiris Stream in Greece, the Dibit River in Armenia, and we have the Arhavi River in Turkey. So once you know now the introduction, the countries that have been involved, we wanted to have a Black Sea, but try to create the main objective to have a joint environmental monitoring system. And this is the hardest part. So we're trying to create something that it will be used by all countries in order to be able to study the results. So we focused on the inland pollutants and the litter from the rivers and watersheds that end at the Black Sea area. You can see here Moldova, Ukraine, some specific objectives. Create this joint monitoring program on pollutants and litters. Also, the coordination of the environmental protection of those areas and jointly reduction to have a reduction of the pollutants and litter through the best management practices. So here we have part of the actions to address the origins of the sediments and other non-point source solutions to the streams and the waterbeds. And of course, the origins that could be the stream banks, you have the slopes, the vegetation, but also the soil surface with different land use covers. So we wanted to see what is actually the potential effect by studying different land use areas. Just to get an idea, one of the measurements that we try to do is to estimate those pollutions through the traditional methods, and this is the erosion pins, runoff plots, but also, as you can see at the photo up there, we were trying to use innovative methods through the drones, indices, and all these new technological tools that we have to study environments. Now here's Greece. This is the area that we were trying to target. So we're getting an idea of what is going on to the Agiris area in Greece. And right here, we can see we have the area is very rich in biodiversity regarding the bird species. We have many amphibians right there, mammals, fish, of course, a lot of plant species, riparian species. And in order to get some idea of what we're talking about for the Agiris, you can see it with the red line with a total length of 65 kilometers and a basis for almost 3,000 square kilometers. And of course, it's from the northern to the southern of the drama. And you can see at this point that I'm showing here, we have the connection of 4 streams, that is the Agiris, Agia Barbara, Xeropotamos, and Zygactis stream of that area. All those areas you can see here, they are coming from steep slopes. So you can see here the Agiris Gorge that is for running for 5.5 kilometers near the Elistratis cave. So you have some unique ecosystems there with caves for some people if they want to visit. So we can see the steep slopes of 100 and 120 meters height on there. Now looking at that point, going down a little bit to the Strimonas River. Strimonas River, some of you, they might know the historic part of Alexander the Great. They found the tombs and they say that it might be Alexander the Great tomb over there. Just to get an idea, this is a great historical area, but this is also the area, and you can see from the photo, a really big flat plain where many agricultural areas meet, and we have the big river of Strimonas. And eventually this one is running into the Strimonikos Gulf and the area of the Aegean Sea from the Greek part watershed. Now we do have problems because, and I'm assuming everybody has these problems when floods are occurring. So all these debris, and in Greece, most likely you've heard this been a really bad year for us, but it's not only for Greece. It's for many, many countries worldwide. The floods are a really big problem, and they are causing biggest problems for agricultural areas. So even if you're here in an area of Katowice and Thessalia, many of the agricultural production has been gone. And this is causing a lot of production problems, money-wise, for everybody, and of course for the economy of Greece. So what have we studied actually over here? You're going to have to be a little bit patient with me. The talk is going to take a little bit longer than the usual. So let's see what is going on with our studied areas. Surface erosion, watersheds, and plot scales that we're having using here. So we can see we have runoff plots and girl-like traps. Many spots over there, a lot of work, a lot of detailed information, and this has been done in order to study any erosion potential problems on different land uses. So you can see here we have some forest areas, some agricultural areas, and we'll get into more details about that. These are girl-like traps that we've used at our sites. And of course, except from that, we've used vegetation indices through satellite images, where we can see where we have the vegetation at our sites. These are very useful tools to use. Of course, we can monitor where we have the usefulness for the drought monitoring for early warning of potential floods of those areas through the normalized difference water index. And also we studied the normalized difference soil index that is actually indicating where we have high salinity. It's a very useful tool as well, especially when we're dealing with production, because we do know salinity is a big problem in many areas. Getting those maps from the study site, we get the NDVI, as we can see here, based on the vegetation. And of course, we have the NDWI and the NDSI based on the water and based on the soil salinity levels. This is very useful for us because we're trying to see where are the hot spots in order to see where we get most of the erosion from those sites. And then these are the targeted points where we can introduce after this point nature-based solutions and some additional alterations on the land in order to reduce the loss of the soil. So here there are some images from the drones that we also used in order to spot those target areas that they're causing most of the problems, but also at the same time, we use the drones in order to get some idea of what is going on into those streams without getting into those streams, just by getting the photo images through different time scales of the drone. So if we take it here at where I'm showing you there, and we can see a cross-section of the stream. We can see the different levels and how this stream is changing through time based on the drone images. So we don't have to go there and take the measurements, but just flying the drone, we can get a very good estimation of what is going on into the river. into the Aguiles River. Now, of course, we were there and we took some additional measurements in order to study those sites and get a comparison between what we get from the drones and what we get from the actual site measurements. A lot of hard work over here. Too many students, they're getting involved, including us at this project. So we're getting stream bank erosion measurements. And right here, one of the most important tools that we had, and very simple tool, is use erosion pins. So these are pins that they're put into the soil, and you get an estimation based on the centimeters of the soil that you lose or it's deposited on the sites. Too many areas, too many sites, too many land uses that they were established there, and we try to get that information. And this is only from the Greek side. This has also been done and conducted for the other countries as well, in order to have the similar monitoring system. So we can see here the digitalized map where we have all those plots. Still, these plots are running. We're taking a lot of measurements on that. When we were on the site, we were trying to put those pins into two rows. Now, the first row you can see on the red, it's 1/3 from the height of the stream bank, and the second row is 2/3 from the height of the stream bank. We put the pins in there, and you go and you measure, and we try to put it in different land uses. So we had to study rangeland areas, agricultural lands, sclerophyllous vegetation, and riparian vegetation at those sites. So we wanted to see where we have the least loss of soil. This is an image for the rangeland area, just to get an idea of how different those sites are based on the characteristics and the images that we get from those areas. And agricultural land, most of us, we have that. We can see on the left of the photo, the river, right next to the agricultural area. And of course, we have the sclerophyllous vegetation. There's sometimes they have that adjacent to the rivers. They're just areas with this type of vegetation. And of course, the riparian, the normal riparian area, where you can see the road here. There are some agricultural areas, but there is a buffering, like the one that I showed you previously at the beginning. So there's a very intense vegetation areas. We do have that, not as common in Greece because most of the land has been used, but we're lucky we have that. So let's get a little bit to the outcome regarding how much soil we lost in terms of centimeters. So at the top, at the rangeland, we have 11.5 centimeters. Going down, we have a little bit more, close to 15 centimeters. And then once we move to the agricultural land, we have similar numbers. We have 11 at the top, and then a little bit less than the 14 than the previous one, but we still have 10 centimeters of soil loss at that area. Now, where we're going to the sclerophyllous vegetation, it's a little bit less on the bottom, but similar values for those three land uses. Now, when we go to the riparian vegetation, there we can see the difference and how those areas actually, naturally, they protect those stream banks not to lose soil. So we can see here 3.5 compared to 10 or 12 from the previous measurements. And at the bottom is only 1.8 centimeters of soil loss. And this is based on pin measurements. So if we take a look at all this diagram, we can see that that was the first measurement that we took from those pins. We still try to go and take those frequently as the measurements continuously. Hopefully we'll have future publication to share with you regarding to those measurements. And based on the drone measurements, because we also tried to estimate that based on the drones without getting the pins, We did get some outcome recently. We had some proceedings. They come out on a book, and you can see here that the riparian areas based on, we call them broadleaf forests, they are less, but also the sclerophyllous vegetation also had some very good research outcome. So it's still a lot to do based on what we have so far in those areas. It seems that the areas that they are buffered with vegetation, they're doing much better maintaining those soils for future production of the agricultural lands. Now, what I really want also to show you here, part of the project was litter traps and skimmer vessel. So just by using, well, this is structured in order to clean the waters from any debris that they're getting in there, plastics, any kind of other debris or wood that they might cause, flooding problems. And so you can see here from the different countries, different views, everybody did the same. I think on the left we have Romania, and on the left we have, I think, Moldova, and on the right must be Turkey. So this is the skimmer vessel that we have. Only Romania got a skimmer vessel. It's more expensive. So this is something that is getting into the lake and is cleaning the waters. And trust me, they had really big pollution problems at those rivers of the lakes, and that lake is a source for water from the adjacent populated villages. So clean water is very important for that. Regarding to Greece, this has been established. If you get a chance to get here, as many people, they come and visit the sites. We have the litter traps. This is the installment of the litter traps. Very good outcome, and it's cleaning a lot the waters. This is the establishment. You can see here how many debris, different things, but plastics. We're trying to keep separate the plastics and trying measurements on these. As you can see here, is being cleaned. We take the weight of whatever debris is getting into there and trying to see, how we can benefit from that. And so far, because this is a big town and people are going and visiting those riparian areas a lot, they're very happy with the final outcome. Of course, there are some sites over there where we inform the people about the benefits, and this is outcome possible, the publications that we got based on the similar measurements that they took place in Turkey, Romania, and Greece. This is the for these three countries, this recent publication. So aiming for clean waters at the Black Sea region, that's not what we should only have in our mind. We should have clean waters worldwide, and this is a big issue for many, many countries. India is not an exception. Greece is not an exception. Africa is not an exception. So reach out globally for long-term sustainable ecosystems. This is what we should have in mind. And this is the lake after cleaning the lake in Romania. Really amazing outcome. Now to us, this is research, this is us, but we're trying to educate. We're trying to reach out different people, different professions, different age levels, different education level people. So they need to know what is going on. So here we have university students trying to educate them. We have high school students trying to educate them about this project and this outcome and the benefits. We're trying to introduce these. I'm sure all countries are doing these actions, and it's a really good thing for everybody to have that. Now this is the cave that I told you about, unique ecosystems. They need to know about those unique ecosystems that they are created by those gorges. Too many outcomes, awareness events. The TV is a good tool to inform people about that. Of course, we've been trying different events with Africa to inform them. This is in Cameroon, and you can see here this is part of the board, but it happened. We educate young kids over there about proper transplanting, simple ways for people to be applicable, not just high-tech research workshops in different areas, but also educating the students at those sites. And of course, here today, we are here educating ourselves, being informed about those things. And this is something very important. It's a global conference. And I'm really happy to be part of this and very honored to be one of your speakers. I've heard a lot of good research work from India, from all over the places, Brazil and worldwide. So congratulations to you. It's really amazing. I've been part of this effort for quite many years now, huh? So I'm really happy about that. So thank you all very much for having me, sharing this. This is a different perspective of agriculture, more ecological, a little bit more holistic, but we should always keep that in mind in order to actually maintain our production. This is very important not to look something narrow for production, but as a whole for our ecosystems to sustain them in order to have long-term benefits worldwide. This is a project, and I'm really happy to be part of this. And I will be more than happy to entertain any questions. Thank you.